engineering for reliability, validation, and safety. Now, once you have an AI system and with traditional software engineering, what is the difference? Now, you still need to have the same rigor, no? You have to do the software testing, monitoring, rollback strategies in case of any kind of breakage. And any incident happens, you have to handle it. For example, a service ticket or system downtime, right? So, but now it's not about accuracy. When you are having a system, a machine learning system, it's just not about being accurate. Uh, you may be 99% accurate, but are you fair? Are you up all the time? I mean, this is robust. Is the system foolproof? Fairness is in terms of ethics. Is it fair enough? Is it secure enough? And can it perform it in the real world? Now, what is this fairness? Okay, so now you have a HR agent. Now you have designed your prompts in such a way that you get good candidates. But if you have designed the prompt in such a way to exclude, say, the gender, which you don't want, right? Then it's not fair, right? So then it will go beyond the validation, right? Let me give you an example. I posted on LinkedIn once last week a job requirement from my organization, and for that job I needed a female candidate because I thought that the role demands a female candidate. Okay, but the agent which is running on LinkedIn, it flagged it that you cannot have a gender bias in hiring. So my job was taken off, right? So that means when you are having an HR recruitment agent, it has to be designed by the product manager for fairness, and this fairness has to be implemented by the engineering team, right? Now, data quality is basically once you have data pipeline, you are ingesting the data. That means you have to clean the data properly. You have to remove any incomplete data, any blank or any incomplete data, or you have to check the validations of the data that is not invalid, right? You could have numbers which are out of the ordinary. For example, if somebody puts height as 27 feet, now if you accept that height, when you're doing average, everybody's height will become 12 feet, for example. So that means just one data point is going to mess up all your data. So that means that has to be identified and deleted, no? Because that data is not right. So like that, the data quality is very important. Then all the models have to be versioned. That is under ML ops. The prompts you're using have to be versioned because you see it's evolving. Now when the code is something, prompts is something which is helping you to design your system. That means the prompts have to be versioned. The human sentences you type in your human language are your prompts, but that's actually code for the system. So there also has to be versioned, right? And then you can do some controlled experimentation also around your pipelines. Now, for reliability to occur, you have to have clear SLAs, service level agreements, right? That this will perform up to this level of accuracy. This is the ethics to follow. This is the guardrail to follow. Guardrail that it will not try to do some kind of slang. It will not try to talk nonsense. All those things will be there, and the system will be up so much of time, like that. Anything which is of high risk has to have human in the loop. Human oversight has to be there. So like that, you have to design the system. So you have to. So all these things are there, right? Then you have to. AI behavior has to be logged and observed, and you have to work with the governance and compliance teams. Governance is about following a proper ethics. The engineer has to engineer those ethics. So that means you have to ensure that the systems are really working properly as designed, essentially. Reliability, validation, and safety.